It was supposed to be a simple repair, but YouTube's greatest Disney media repair tech had no idea what was in store. Every clue uncovered another mystery. A PWM chip that couldn't be trusted, a feedback circuit that had been tampered with, components in the wrong places, and one final resistor, tilting the balance of power. Join me over the next 3 episodes as we stroll through the circuitry and revive this nostalgic collectible. The hunt begins now. Before this video starts, I want to talk about this stuff. This stuff has changed my life. Fast chip, a low melt solder. It makes component removal so easy. The components will just fall out. Nowadays, everything's made with unleaded solder. It has a higher melting temperature. It doesn't flow that easily, but this stuff will lower that temperature down, keep it liquid for a few seconds, and it just makes removing things like these multi-pin chips just so easy. Here we are, back at it again. Another Disney DVD player. This one's the pink one. Customer sent it to me in pieces after he attempted a repair. Funny story about how I met this customer. He posted and asked for help on a Facebook group that I'm a part of. And then after we got to talking, he said, "Wait, is this your YouTube channel?" And he linked the video of me fixing that other Disney DVD player. So that was kind of a funny way to meet him. He said he was trying to reach out and contact me on that channel. I don't check the comments that often, so I missed his comment asking for help. But here we are. This thing's here. What I understand that he's done, he's replaced this PWM chip here. He replaced the optocoupler here. And if I had to guess, likely not the failed components. He sent me a bag of parts, some generic ones he got off of Amazon, I think, which I wouldn't recommend really getting things off Amazon. You don't know what you're getting. Use DigiKey, Mouser, Jamco. He's replaced a few of these capacitors. Again, I think he got them off of Amazon, so likely not low ESR. I'll have to check that right off the bat. Something I did see, and this lets me use a new little tool that I bought to kind of highlight it. There's this little, if I can get that in the shot here. This is a kid's microscope, but it helps a lot when you're trying to see things. You can see kind of in here. Let me move that out of the way again. This trace right here going to the optocoupler, that's torn right here. It's no longer on the board. So that could be part of the problem as well. There's no regulation when this is disconnected. We'll see. Before removing this cable, I'm going to bridge the laser diode. Looking to protect this laser diode here. It's one of these latches you gotta slide up, and then you can remove the cable. Now's a great time to hit that like button, and if you want to see more repair videos, hit that subscribe button. Alright, DVD drive can be set aside. Checking the screws on these. Alright, that one is a machine screw. That one, plastic thread down there too, just to keep track. Oh, there we go. Looking at this more here. This is also destroyed, this trace here. I'm not sure if that's actually connected to anything. I think it should go to this. Was it a 220 or 22 actually? I think that's 22 raised to the 0. All right, that might be destroyed, but I think we can make a little jumper there. I'm not that skilled in micro soldering, so we'll see there if that actually works out. But if you look on the back side here, the trace is also just blown out right here. There's just no trace left here. Granted, I think it only is on the top side, but they have a through hole here. I think they call it a via that comes through that should connect it to the other side. So I think we're missing a signal there. I think I should repair the board first, if that makes sense. Make sure we have all the connections correct first. Probably not a great view, but I'm gonna try to get in here. We're just gonna cut that trace right there. There we go. Cut that just off. Oh, that flew into the board somewhere. Man, you can tell this is live. Oh, there we go, right there. Move that out the way. Alright, right here where my thumb is, we gotta repair that trace. I think it goes into this resistor here. I think that's where that connection goes. Can confirm with this. Let's see if we have continuity between those 2 points. Actually, I think before when I checked it before, I think I already had that. Yeah, hold on. Let's make sure we're not crossing wires here. Right on that? Yeah. So we're supposed to connect there. All right, I hope and a prayer that this is going to work. Let's see. Nope. Already ruined it. I didn't get that on the camera, but by complete luck, I think I soldered this wire here. This one needs to still go there, but it is in perfect position. I need to get them under the microscope, but it looks connected. It's not great. Let's get some more flux in here. All right, come on now. Nope, 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 nope. I don't know. Maybe. The whole thing is so small that it heats up the entire thing before I have a chance to do anything else. It's connected, it's not well. I think that's on. We can test it. I think it's on. Try to wiggle this. I mean, look, it might be on there. I don't think I really quoted the guy a price for this, but you're coming to a YouTube technician here. All right, I'm not a professional here. I think that's on though. I think it's all connected. It's not great, to be sure. It's not great. We can see how this looks. Do I get an ohm reading across this? If I poke here and I poke there, yeah, I'm getting an ohm reading. It must be connected. I'm getting an ohm reading from this here to the opposite pad there. So that's connected. One down. This other one, I think literally, we might just be able to solder, blob it. I don't know, dude. Let me come back with the reader here. This one to this one, are we getting anything? Oh, well. The trace exists here. It's not great soldered in, so we're gonna redo that, but the trace at least still exists on that side. The underside, it's completely blown out. I don't think it needs to exist on the underside though, because this is the optocoupler, and all this really does is it helps regulate the power supply. So I've never talked about an optocoupler. I don't know that much about them, but from what I understand, there's an LED on this side and there's a receiver on this side that can see the LED, and depending on how the power is on the secondary side, if the power is too high, the LED shines really bright. This sees that brightness and maybe increases or decreases the resistance across these two terminals, and it tells the system that, hey, you need to turn it down, it's too bright. That's basically a really simple explanation of what this does. That one's better. I guys like saw a hairline crack develop because it was too cold. That trace is lifted too. If you were to take a really close look at it, that one's kind of ripped. It's not great. My micro soldering skills really aren't there, but I think we're connected to the trace. There's no trace on the backside here. So we're like loaded up on the front end. All the solder is globbing on the front because there's no trace on the back end. Let's clean this up. Where'd my isopropyl go? There it is. Let's just clean that up. How well is this little component on the board? That's on there. Okay, that's connected. On to the next part. Next part here is just going through these capacitors and seeing if they're low ESR or not. That's fairly low. Granted, they're soldered in, but that is pretty low. You know what? Let's have some fun. Let's plug it in. Let's see what happens. Everything's connected to my dim bulb tester and an isolation transformer. We've got minimal assembly. The laser's not plugged back in. That probably doesn't matter. I don't think it needs that load to work. Let's see what happens. Do we get a light? Nope, no light on the screen. All right, gotta dive into this thing a little bit more. And yeah, we have no amperage draw on my kilowatt, so it's not even trying to start. All right, well, tearing it back down. All right, I've got everything plugged in, turned on. We've got the right voltage here. One should be about 168, 172, that's probably fine. But there's nothing coming out of the secondary here. When I measure across these, you get nothing, so this chip's not firing for some reason. So we have power coming in, we do not have power coming out. For this next section, I'll preface that I looked up the PWM chip's part number and I found the data sheet. So that helped me in determining the next steps, which you'll see in this clip here. Something I just found, so we've got ohm mode here. Pin 7 to 8, which should be power to ground, is 13.7 ohms. That's way too low. The only other thing in that circuit that is in parallel with that is this startup capacitor and the Zener diode. So it's one of these two, or the chip itself, something's shorted. So 13.7 is either happening here, or happening here. It's shorting that out. For example, the other chips that the customer sent me, it doesn't even register. That's how it should be. They're isolated from each other. Reverse direction, quite high in the mega ohm range. That's what it should be, I think. All right, so I lifted the legs of this Zener, so it's no longer attached. I lifted one leg of this capacitor, it's no longer attached. And let's see, still that 13.7 ohm resistance. I did notice that there is actually another Zener connecting over here, but if I measure that Zener across that Zener, the resistance is actually pretty high in the reverse direction, and in the forward direction it's quite high as well. I think it's the chip itself. That's the only other reason, or the only other thing that could be shorted. I don't think there's anything else on this trace here. I'll keep looking though before I remove the chip. All right, here's the chip I just pulled out. The power to ground pins are sitting at 13.7. That is way too low. Here's a brand new one. Open circuit, that's what you want. So this device is internally shorted. Somehow, maybe it got overheated, maybe it got damaged. Before I start, let's just take a look at the pads here. Mostly look okay. That one's a little, this one's rough, but this one's missing some. I might solder above and below to make sure we've got good contact for both sides of this via. That one looks good. I think this is a ground plane underneath. That looks okay. That's the main power pin. Yeah, overall, I think it looks good. I'll apply some flux while I wait for my iron to heat up. I've kind of liked these dental picks. I got them at Hobby Lobby, and I slept on Hobby Lobby a little too long. I didn't actually realize they might have things for my actual hobby. I thought it was all just like crafts and stuff, but I got this pad here for it, the little silicone pad. I got these dental picks, which helps me grind away some solder masking from time to time if I need to, or on these small components, just add like a little bit of flux here and there. Start solder. I should put the fan on. I suppose this is the moment of truth. The new one's in. What's the resistance from that to this? All right, good. I think that is better, definitely better. It should be a high mega ohm because we don't want a direct short to this. This might be the measurement based on like the capacitor and zener that are also in parallel with this leg. So that's something. Moment of truth here. It is reassembled enough to test. Going to fire it up in a second. Do we have lights on the dash? No. No lights on the dash. Got no current draw. Let's see. Hopefully it didn't just blow the chip out. It didn't turn on, but we have activity on the primary side. 12 volts there. This is a different board than what we started with. 0603 minimum assembly for testing purposes. Does it turn on or does it blow up?